Hello everyone, good morning. Today it's gonna be a vlog video and I'm gonna be showing you guys what I'm doing today, and I'm gonna be working with cell lines. So right now I'm heading to university. So let's go and see what I do today. It's pretty sunny today, so I'm wearing my sunscreen. So you all need to remember SPF 50 and plus is necessary. So yeah, sunscreen is a must. I have like so many keys. It's of that lab, this lab. I'm like, Jesus, sometimes it's so heavy to even carry it. Jeez. So the basic biology behind cell culture work is that you take out the cells from the plants or animals and you grow them in artificial culture and media. So usually it is grown in vitro, and it is given essential vitamins, media with the different serums so that they can grow and thrive. And before we can do any experiment on human or in animals, we try to check them with the cell culture work to see if it can be really used as a therapeutic property. So right now I'm planning to go to cell culture lab, and in the cell culture lab I will be splitting the cells as well as freezing them for the future use. So basically you freeze the cells and then you place it in -80, and later you put it into liquid nitrogen, and after that you actually use it for the future use. So that is like cells that are primary cells of rabbit. So we have adipose tissue as well as the tissues from the mouth. This is our lab, and this is a cell culture lab. Over here you cannot bring your outside lab coat and everything, so it should be just kept here so that we don't have any sort of contamination. So I came pretty early. It is not even 8, so it's empty. So this is the cell culture room where there is 2 laminars present. So these laminars over here, you only work with cell lines. You cannot work with bacterial cultures because they can cause contamination and you won't get the results that you want. So this is how it looks. So over here I have cells from the adipose tissue. Both are adipose tissue cells, but I have a note from my fellow PhD student that I have to freeze them today. It's really cute when people leave a small note for you. That's Eva actually. And yeah, I'm gonna first observe it under the microscope and then continue with seeing the status and the confluency, that how well they have grown. If they have grown really well in this flask, then I'm gonna freeze them by adding trypsin, PBS, and all the solutions that I'm gonna show you. All right, this is the water bath. You just turn it on because these medias are kept in fridge. That is 4 degrees Celsius. So this is the trypsin to which the cells detach. This is the media, that is BMC, there is IMDM, there is MDM. So there are like many medias. Look, you need to see what cell lines use what media. So this is prepared by me before. So I think I'm gonna use this up first and then later take this one. And this is FBS, which is a media through which cells gets vitamin and can it helps the cells to grow. And then this is PBS, sterile PBS, which needs to be washed. The cells needs to be washed by the sterile PBS, which is phosphate buffer. And I'm just gonna turn this on. Over here it has been set to 37. So it's just gonna warm the media up, and I'm just gonna place all the medias here. And I'm just gonna let them warm up now. You don't have to place FBS because it's just in plastic container, which will just get warm easily in the room temperature. Right now, I'm going to be observing these cells under the microscope just to see how well they are actually growing. And I can see that they have grown really well. It's so good. The growth is so good. So this is like the focus of the light. So I can just change it, and if I need more light, then there is like more wavelength of light. If I need less, then it's less. So over here, you can actually change the magnification. You can make it 10x, 20x, 40x, 100x. So over here, I did like 100x to see how well these cells have grown. So they're pretty confluent. So I think I'm going to freeze them now. And I need to check a smaller flask as well. Yes. Okay, they have grown pretty well. There is no contamination. So you have to always make sure that there is no contamination, because there are small bacterial cultures. Sometimes they enter into the flask, because I still wonder how, but they do. And when it gets contaminated, it is pretty tricky to work with the cell lines, because most of them die and these bacteria take up the media. This media you can see, and the cells don't have anything, and apparently the cells die and the bacteria thrive and grow more. So I have placed everything inside the hood. There are my cell lines that I'm gonna work with. There is FBS, there is PBS, and all the media that is necessary for freezing as well as splitting the cells. And I'm gonna start working with this. It is very essential to spray your hand, because the cells can easily get contaminated, and it's crazy because you cannot just avoid it. So you need to always take precautions. So right now I'm gonna centrifuge it. I have placed my vial with the opposite side is also with the same volume. They both are like 15 ml. 1500 for 6 minutes is the requirement. So it has started. So after 6 minutes I can use it. So the thing about primary cell line is that they grow really slow, and you need to be really careful when you are splitting it, or else when you are trying to freeze it. Sometimes it takes like 1 week to even grow or make the flask totally confluent. Rather than in the cancer cell lines, they grow pretty fast. They grow within 48 hours, 72 hours. It doesn't matter for them. They love their media and they like to thrive. But in the primary cell lines, they are very tricky. They take time. Their media needs more vitamins, more nutrients for them to grow, because they are from a live animal. This is the freezing room. Over here, there are all freezers, -80 freezer. So over here, I'm gonna place my cell lines, and I have already put them in the vial and then place them in the ice. That's how is the protocol. So you just cannot just randomly bring it, because it has the DMSO, which can kill the cell lines. So you need to always place it in the ice so that it can freeze a bit, and then directly place it in -80 freezer. So over here, I'm placing these over here, and one more goes here. These are the boxes that is specially for the cell line storing in -80, and that is how -80 looks like. It's damn freezing, so you need to be very careful. Place it here, and that is it. So that is it for this video, guys. Thank you very much for watching. Make sure that you subscribe to my channel, and I will see you soon with another video.